Good morning, friends. Our today's topic is viscosity, and that is denoted by mu. Now we'll see what is viscosity. That is property of a fluid which offers resistance to the movement of offers resistance to movement of fluid molecules. If we see by an example, suppose there is a pipe cross section. This is pipe cross section, and if water flows through this pipe, now this one is water. If we see the velocity profile of these fluid molecules, liquid molecules, the velocity profile is like this. That means this is velocity profile. At this point boundary, the velocity is 0, and that is increased at the maximum. This center of the pipe means it is maximum at the center of pipe. Again, it is decreased to the boundary. So we are saying it as no slip condition. If we see the shear profile in this pipe of the fluid molecules is like this. This is shear profile. That means at the boundary the shear is maximum and it decreases at the center of pipe, again increases to the boundary. If we can see the example, if water flows on a road after rain, the at the boundary the velocity of water is less, and at the center velocity of water is maximum. That is the technical example. Now if we see the velocity profile on x and y axis, this is x axis, this is y axis. On x axis, if we represent, that is change in velocity, and on y axis if we can see this change in the distance. The profile, as we have shown, is we are drawing here. That means if we go inside to the center of the pipe, suppose at any point the velocity of the particle is u, again towards the center the velocity increases, and that we are going to show by u plus du, suppose. So this profile we are seeing it as velocity gradient or shear deformation. That means velocity differentiates after going certain length. Because of this differentiating, the velocity viscosity occurs. Basically, will come towards the viscosity. How the viscosity terms came, that is by the formula, that is tau is directly proportional to du by dy. Now tau is nothing but shear stress, and du by dy is the velocity gradient. Before seeing this formula given by, or we may also say it as Newton's law of viscosity formula, the shear stress, we'll see what is shear stress. Shear, before the shear stress, we'll see what is normal stress, and then we'll go for shear stress. Normal stress is, if suppose a body is there and the force is normal force that is applying on this much area, that is A, so we'll write it as sigma, that is denoted by the normal stress, F divided by A. Now this F is normal force, that is perpendicular force. If we see shear stress on the same body, that body is like this, on the same body, the force is now tangential force and the applying on the same area A. Now here the shear stress is denoted by tau is equal to F divided by, so that is the basic difference between shear stress and normal stress. So this is shear stress. So tau, if we get this sign out, that is proportionality sign, tau is equal to mu multiplied by du by dy. To get out this in proportionality sign, here the mu is viscosity, or we may say it as coefficient of viscosity. This equation also call it as Newton's law of viscosity. If we see this equation or this equation by an example, that is example, suppose there is a pond, this is pond, and there is some water here. If we drop a stone like this in this water, what happened? Now this stone drops here is going to apply some shear stress, that is tau. Because of this shear stress, some waves are developed. Now these waves, we are saying it as du by dy, means the velocity gradient, velocity, we'll write here velocity gradient. So we are directly say it as tau is proportional to du by dy. Because of this stone, the waves form, and that also say it as shear deformation, means deformation occurs. Because of this stone and because of this shear stress, shear deformation is going to take place. If we see another example, we'll take the bucket. In that bucket, suppose now we pour the honey, honey is there, and if we empty this bucket, so what happened? This honey goes up to certain point. After dropping down this honey, it will go up to certain point. The other example, if we take, that is of water. The another bucket is there, and in that bucket, suppose the water is there, and if we pour that water, that will go to the farther distance up till this point. So this is the basic difference because of the viscosity. In this case, viscosity is maximum. In case of honey, viscosity is maximum compared to water. So these are the technical examples related to viscosity.